My name's Stephen Cho from Team Analytics Anonymous, along with Xiao Chenjing, Yang Yang, Yishan Li, and Leo Wang. For anyone that uses public transport, I'm sure we've all faced situations like this during peak hours. We aim to build an app to help identify when and where the network is overloaded.
We will demonstrate our app based on the tram dataset from 2017 to 2018. Now, starting from the Overview tab, we immediately see where the network is experiencing most touch-on activity by stop, and we can hover over each bar to see the stop name for AM peak as well as for PM peak. Now, we've got some default values here on the left, but we envision this to be a live system. Now, if we look a little bit lower, we can also see some general statistics on the number of touch-on transactions over the time period in the bottom left, and the card type split users in the bottom right, and we can hover over each of the pie slices to see more details. And we can also further interrogate this data by changing to specific route, for example route 3. And we can also do multi-route analysis by selecting another route. And we can also change it by card type, for example seniors only. Next, we want to look at population movement. Where are people getting on and off? To do that, we needed to first address the fact that
most tram users do not touch off.
Using inference, where if for example a user touches on in the morning at Box Hill and in the evening in the CBD, we infer that he must have gotten off in the CBD in the morning and Box Hill in the evening. If that didn't work, then we use known user travel information to create a probability matrix for users getting on each stop. Using a simplistic example for any set of variables, if we know the probability of which stops users get off at based on origin, we can generate a matrix like this on the right. Now imagine an entire matrix with all the possible touch-on-off stops, something like this. This allowed us to probabilistically determine touch-off stops for users who didn't touch off based on the same variables. Similarly, using user travel patterns, we could also retrieve all headless mode data.
now that all users have a matched touch on and touch off, in the Movement Analysis tab, we can generate here on the right what is called an origin destination matrix. It'll essentially where people get on and off at a selected particular route during a particular time and during a particular month or day, which you can change up here. Using a color scale which indicates how many people, we can also see by the color clusters between which origin destination pairs using the XY axis, where most of the movement is occurring. These graphs on the left here show the number of people that are touching on at each particular stop, as well as the number of people that are touching off at each particular stop. And we can hover over each bar to see the stop name as well. Finally, we have the Load Analysis tab where we show visually on the map the route selected, for example here Route 96 between 7 to 9 AM, and it indicates which stops are experiencing high load in red for both directions. And we can hover over each stop to see the stop details, and we can also zoom in. And we derive this data from what we see here on the right, where we calculate the average number of people on any given tram during the time interval selected, and if it goes above a certain threshold it turns red on the map. And we've got two graphs for both directions. We have compared some of our values to a previous report from the Metropolitan Tram Load Standard Survey Report 2017, where they used manual counting of tram loads, and we observed similar results. Our app can also be applied to buses, and with a few adjustments potentially trains as well. Thank you for listening, and I hope you'll enjoy using the Yarra Tram Load Runtime.